In the following set of definitions, we're going to be looking at the second derivative test for concavity, and we're going to determine whether something is concave upward or concave downward, and then we're going to define a point of inflection. So concave upward is pretty easy to understand. What the definition here states is that if the graph of f of x is everywhere above all of the tangents to the curve in an interval, then the curve is said to be concave upward. So let's illustrate this first. Let's draw a picture. So suppose our curve looks something like this, and now what we're going to do is we're going to take some kind of tangent, and let's pick some point here. Well, notice that the curve is everywhere above all of the tangents. So we could draw another tangent, suppose off in this area, and the curve is still above our tangent. And let's try something down here. Again, the curve still above our tangent. So that part of the graph is said to be concave upward. And the test for this is obviously when the second derivative is greater than 0. So that's what we're going to do if we want to evaluate a function. Check where its second derivative is greater than 0. Now to check for concave downward, well, we'll do a similar test. So the definition there says if the graph of f of x is everywhere below all of the tangents to the curve in an interval, then the curve is said to be concave downward. So what we're going to do is we're going to sketch a curve, and suppose it looks something like this. Alright, well now let's go ahead and draw some tangents. So suppose we have a tangent here. Okay, and how about a tangent there? Well, notice that the curve is below all of the tangents in that area. So then this curve right here, this part of the curve, is said to be concave downward. And well, let's take a look at another graph of a function. Suppose it looks something like this. Well, notice that this part right here, and let me line that out in a different color for you. This part right here is concave downward. This part right here, of course, concave upward. And there's some point somewhere right in between. Suppose it's right in here. That right there is what we'll call the inflection point, and this is very important. One test that you might have already guessed is that this is likely where the second derivative is equal to 0. Now, this isn't necessarily true in every case, but this is the test that we'll use. Well, where is the second derivative equal to 0? Now, the important point is that the second derivative must change sign within that interval. So it's pretty clear that we have concave upward on the left-hand side of this graph, right in this area, and concave downward right here. Well, again, you need to do some tests, but as long as the second derivative changes signs within those given intervals, then we do have a point of inflection. So to find the point of inflection, of course, what you'll do is set your second derivative equal to 0, and then you'll notice, well, where's my second derivative greater than 0? That's concave upward. Where's my second derivative less than 0? That's concave downward. So this is just a brief explanation of what it means to be concave upward, downward, and a point of inflection.
Made with Doodlecast Pro.